Hey everyone, welcome back. This is lesson 3 of the programming course. Let's see, last lesson we talked about variables, right? So we had variables, integers, decimals, Boolean values, trues and false. And we're going to use Boolean values a lot to learn what Boolean logic is, and then use Boolean logic in if statements, switch statements, and general selection of something, right? But let's first start with Boolean logic and let's jump into it. What is Boolean logic? If I were to say to you, if something is true and something else is false, I want you to do some sort of calculation that yields whether or not something else is true or false based on the first two inputs I gave you, right? That sounds a little weird. So for example, I want you to tell me should drive fast. Should I drive fast? Well, you should drive fast if you are running late and it's okay to drive that speed limit, right? Or as long as you're not breaking the speed limit. So let's say that I have two variables. One is called is late, and the second variable called is within speed limit, right? So should I drive fast? As long as fast is in the speed limit, please don't go out on the roads and start driving fast. So let's say that the first one is late is true, and the second one is within speed limit. You know, I don't know what that really means, but anyways, is within speed limit is false, right? There are three ways that we can really compare these two values together. Now, in my example, I said, if these are both true, then drive fast. So the first one was true. So are you late or is late is true. And the second value, which I'm going to place over here on the right-hand side, is false. And according to that calculation of true and false will generate true if and only if the data compared are the same, right? So if one is true and the other is false, are they the same? No, that means that this will yield a false. So if you set that equal to like should drive fast, the answer should be false. The second comparator is the or. If I put that between the two variables, is late over here, and then is within speed limit, the or says generate the value true as long as at least one of the comparative data values is true. Right, so if I said, you know what, you can drive fast as long as you're within the speed limit. I don't care if you're late or not. Or if you are running late, but even if it's outside the speed limit, which I don't encourage, please don't do that, go ahead and drive fast anyways. So if I said is late false, but is within speed limit true, this would still generate a true. Before, that would generate a false because not both of them are false. I mean, not both of them are true. So it would generate a false. If one is true and one is false, or if both are false, it generates a false. If one is true or the other one is true, then generate true. That's essentially why this is called the or, because it's like if one or the other is true, then generate a true. By the way, in order to make this, just hold shift and then hit the backslash, which should be right above the enter sign. It's a vertical line that's called a pipe. Two pipes is the or comparator. The third one is a little strange. This is called the XOR, also known as the exclusive OR. The exclusive OR generates a true similar to the OR, where one or the other needs to be true, but the exclusive OR says also that not both of them can be true. So it will generate a true as long as one and only one of the two inputs is true. All right. So if I have true and true, it generates a false, right? Or would generate true, and an and comparator would generate true. But the XOR would generate a false. Let's kind of make a table with this actually. Let's see if I can make a table with this. Let's put that there. Let's minimize this. Open this up, put that on the right hand side. Okay. So let's say I have two values. Let's just say I have two Boolean values. One is true, I'll just put a T. And the other one is, just for the sake of simplicity, let's say false. Just for now. In code, you're actually going to do you would define these as Boolean, right? Boolean A, Boolean B equals true. You have to spell it out true, and then semicolon, etc. All right, so let's say I have A and B, and I want to assign that to another variable C. Whoops, that's a terrible C. Let's say I want to assign that to the variable C. In this case, because A is true and B is false, remember that this will generate a true if and only if the data compared are the same. Are they the same, and are they both true? That's actually what I should rewrite, that it'll generate true if and only if both of them are true. So this, in this case, would generate false. So if I were to print C, it would print false. If I did C equals A or B, it would generate true. Because we look at this and this says, is this one true or this one true? Yes, then it's true. That's why before it's this one true and this one true? No, they're not both true, so it generates false. C is the comparator, I'm sorry, the third one. If A, X or B is true if and only if one is true. One and only one is true. In this case, this would be a true. And then C, the last one is not actually a comparator. What it is actually an inverter. So if I did C equals not A, this would equal false because A is true and not says to invert that. So the opposite of A, I'm sorry, the opposite of true is false, therefore C becomes false. Okay, that's what that means. So let's create a new program. We'll assign manually a handful of Boolean and numerical values, compare them, and print them to the terminal. Obviously, we've only dealt with Boolean values right now, so let's create a new class, which I already did, sorry. Create a new class, call it whatever you want. Or I'm sorry, create a new project, call it whatever you want. I'm going to make a new class. My project is called Boolean Practice. And I'm going to say that the class is called Selection Practice. Just like before, I'm going to get rid of all the comments. I'm going to leave, you have to leave the class up there, so you should see just this. Pause the video if you need to kind of, copy whatever is happening here. But we need a place for our program to start, and that's the main method. So just like we did before, we do public, static, void, main, string, args. Args is just short for arguments. It's a variable name. You don't need to really know that yet, but it's just a variable name. Whoever decided args, I can actually have it be whatever I need it to be. But that's just the standard. Args is just the standard. All right, so let's say we have a Boolean value A. Yeah, let's do it lowercase. Equals true. And Boolean value B equals false. Remember last time when we talked about variables, make sure your variables are meaningful. I don't have an example off the top of my head, so I'm just using the characters A and B as variables. This is not good practice. Don't do this in the future, but I'm just trying to make a quick program here, so hopefully this should be simple enough for us to learn off of. All right, so let's say I do Boolean C equals A and B. What will this generate, right? Well, we can print that system.out.println C, and that will just print the value. So on the first line of code, we make a variable in memory, and then we assign it the value true. This is actually 2 steps in one line. Then on the next line, we create another variable called B, and we set the value to false. Then we create a third variable called C, compare the first 2 values together using an AND comparator, and based on the comparison of these 2 things, we assign it to C. And then we simply print it to the terminal. So let's go ahead and quickly print that. Okay, false. This false right here, by the way, was from the last execution that was supposed to clear. So it generates a false. And why is that? Well, remember that this yields a true only if both are true. So if I change this to false, let's see what that compiles to. Let's see if I'm right. No, it's a false, right? Because like I said, it's only true if and only if both are true. So in order to make C true, we would have to have this be true and this be true. And compile. Oops, where's that damn terminal? Oh, there it is, true. I'm going to clear this, close this, and there you go. It prints true if and only if both are true. Now you can change this however you want and put this back to false. Compile and run. True. So remember that the OR, which is what this is a comparison for, two pipes is an OR comparator. It says if one or the other is true, then yield true. That's why C is true. That's why we print true. Okay, so this sounds really, really basic. And remember that you can get your true and false values in many different ways. Let's see. And even though this is just like a single kind of comparison of just two values, you can have as many comparisons as you want. Typically, they go left to right, but there actually is a hierarchy that we're going to cover in a second. Also, this comparison of trues and false is going to be useful when we do talk about if statements in just a few minutes. But let's just move on to the next part to see what else we can do. All right, comparators. Comparators compare two numerical values and yield a true if the comparison is true. So these are integer comparators, not Boolean comparators. So Boolean, you have to do trues and false. You have to compare trues and false with ands and ors. However, you can't really do that with you can't really do 5 and 5, even though that does actually make sense to us verbally. It doesn't make sense to a computer. So how do you compare integers or decimals or other things? So you have a list of comparators. Let's say you have an integer, two integers, right? The number 3 and the number 6. Let's say we put 6 on the left and 3 on the right. If 6 is greater than 3, which yields a true, then our value is going to be true. So we're comparing two numbers and generating a Boolean value. This is the greater than symbol. I should really fix this, but this is the greater than symbol. Checks if the left is greater than the right. If so, yield true. Greater than or equals, checks if the left is greater than or equal to the right. If so, true. Then we have less than or equals to. Equals equals is the comparator to make sure that both are equal. Checks if the two values are equal to each other. So if they're not equal, even by a little bit, it will, if they're not equal, even by a little bit, it will yield a false if they are not equal. And the opposite to that would be this not equals, right? So remember how the exclamation mark is the not in Boolean values? So we're saying, are these two values not equal to each other? Yes, because 6 and 3 are not equal to each other. Therefore, we get a true. So actually, you know what? I know that we just talked about it, but let's kind of change this so we have like int. I don't know why I'm writing so big. Int a, int a b equals 6, 3. And then Boolean c equals a greater than b. Right, so we have to create a Boolean value called c, and then we have to do some sort of comparison. So in this case, a greater than b will yield a true, so c will be true. So if we print it, it'll be true. If a greater than or equal to will still be true. If it's less than or equal to, then it'll be false. And then if it's not equals, that'll also be true. Or if I do an equals equals, it'll be false. So let's actually go into our program and create two new variables, int d equals 6, int e equals 8. I know I said 3 in the example, but we're just changing things a little bit. And then Boolean f equals d greater than e. So the reason I'm kind of doing this, by the way, where I create two values and then I create a third value that is a Boolean value, is so you can go back and change things. So you can change these to be integers and doubles. You can change them to be to doubles, different integers, and so on and so forth. And then what you can do is like it's just kind of sections where you can play around with the inputs, outputs, and variable types, and then print them to the terminal. System.out.println f. Right? So let's go ahead and print that. I'm going to go ahead and actually comment this out. There is a way you can comment out a whole chunk of code. Just Google it. It's really simple, but I completely forgot to double check before making this video, and I'm not going to bother. So there you go. Just going to comment out the first section so we don't print out true or false twice, right? Once up here, and then it goes to the next lines, and then down here. So is D greater than E? No, so this should yield a false. Where are you? There it is, the false. Okay, so now you know how to compare Boolean values together, and you know how to compare integer values, or not just integer values, numerical values, right? Integers are the most common because the chances of you getting to decimals to be exactly the same is actually pretty darn rare. It's not impossible, it's just rare. Integers are a lot easier to kind of compare together, so it's just more typical. But it doesn't mean it's impossible. You can compare any two things that you want to, well, not just any two things, but you can compare any two numerical values that you want, and it should generate true or false. It's just less likely when you're talking about, floating point, double floating point, or other things. A warning here, and that's why I put it in really big letters, do not compare reference type variables. When you compare two things such as numbers, you are comparing the value. But when we talked about yesterday, or not yesterday, the last video, when we talked about reference type variables, what you're actually going to end up comparing is their values, which are actually references. This used to be true for strings too, but Java, C#, and maybe C++ recently changed the way strings work, and are now stored in something called a string pool. So let me kind of explain these 2 points. The first point is try not to compare to reference type variables. Again, this may change, and this may have changed. I know that these kinds of things change all the time, and the way that they actually work kind of changes. But let's say you have a reference type variable, which we don't know what reference type variables are, but let's just look at if this was in memory, right? We create a reference type variable, and the reference data is over here at memory location 1, 2, 3, 5, right? That means that this value in here is 1, 2, 3, 5, and is a pointer that points to this location in memory. Now, I create another reference type variable, and the reference data is at, let's say, 890. So in here would be 78900. Therefore, this is a pointer to this memory location. These numbers are the numerical addresses in memory. So even if these two objects or two bodies of data are completely identical, if I do a comparison of A equals B, what you're ending up doing is, because this is just comparing the values inside of here, what you will end up doing is comparing the numerical values of the addresses by accident, sort of. Because like I said, these two things, this data can be absolutely identical. Every single thing inside of it can be identical, but it won't matter. Oops. It won't matter because that's not what you compare when you compare something. So this will be false because 1, 2, 3, 5 and 7, 8, 9, 0 are not the same. Okay. This used to be true for strings as well, because strings are technically reference type variables. But these three languages have actually changed something about the way strings work. So strings used to work the way that I showed you up here. But the way that strings now work is every time you make a string, it goes into a specific allocated section of memory dedicated for strings. All strings, I'll just write strings. So every time you make a new string, it actually goes in here. So if I say hello, right? So I create a reference type variable, a string variable, and it says hello. It's going to point to how do I undo that? We will create the string called hello, and it'll go into this string pool. Then I'll create another variable, and it'll also say hello separately. Typically, if I do this, by the way, this is how we would do that. I'm going to point that arrow there, but this is how you would do that in code. So you would do string A equals hello. Oops, I forgot to close that off. String B equals hello. Technically, if this was still the old way of doing things like this, what I would have just done was make a string variable and point it to a location in memory where it says hello. This is the old way that it used to work. Then on the next line, I made another variable, and then I pointed it to a location in memory that said hello. So it makes literals, because these are string literals because it's the actual string, and I just made them completely identical, but they point to different memory locations. In the past, this would have generated a false. If I were to compare these two and say, are they both equal? It would have said false. But now, because of the new string pool and the way that Java has changed, we create the string once, and now the compiler or the system will first reference the string pool before creating a new string. This does help make it more memory efficient, but also allows people to compare strings now. This is the only time that I would recommend doing this. It's not guaranteed that the language you're going to use in the future is going to do the same thing as well. It doesn't mean that they're going to compare two reference type variables in the same way. It's not going to crawl through and actually compare data point by data point. It's typically going to compare the reference memory addresses instead. So in fact, if I do that, this should be true. Hopefully I'm not wrong, but from what I understand or what I've read, it's changed several times in the past, but let's try it. A equals B. I can reuse A. Yeah, actually, you know what? Just to keep things kind of consistent here, let's do A, B, C, D, E, F. Let's say G, and then H. I forgot the S. System.out.println. There is no A and B anymore because I got rid of them. G and H. This should be true. Hopefully it's not. If it's not, whatever. I don't care. I'm moving on. Let's see. There it is. True. Okay, and it's true because, again, we're utilizing that string pool. This is actually very important. Whoa. This is actually very important because strings are the only things that I know of that work like this. I don't want to really sit here and create two objects because we have not talked about objects yet, but it'll be something that we do once we get around to objects. Okay, spent a little bit more time on that than I wanted to, so let's move on. Now, we've talked about comparing Boolean values using ands, ors, XORs, and nots. We've talked about doing some comparisons with numerical values, and now we've just kind of demonstrated how you should be careful with reference type variables and how strings work a little bit differently than other reference type variables, even though it's technically still a reference type variable. All right, precedence. There is an order of precedence for these operators and comparators. The following table shows you the order from highest to lowest. So postfix. When you do plus plus, remember how in the last one I said there's a kind of a shortcut? Did I mention it in the last one? I've re-recorded these videos so many times I forget. If you take an integer and you do plus plus, right? And I do like 6 plus plus. At the end of this line, the value of D is going to be 6. But as soon as the code starts the beginning of the next line, before it does anything else, it's going to increment D from 6 to 7. That's what plus plus is. It's a shortcut for saying plus 1. So 6 plus plus is the same thing as saying D equals 6 plus 1, except it happens after the line of code. If you do plus plus 6, then it actually increments 6 first, so it becomes 7, and then stores it into D. These types of operators, like the plus plus and minus minus, are done first, right? So postfix and unary, prefix, those are the unary operators, those are done first. These are actually a relatively on the same line or hierarchy of importance, but it gets a little shady when it comes to the plus plus and minus minus. Multiplicative is then next. So you increment, decrement, negate, and the I forget what this one is. I've never used it before. Whatever, but the not symbol. Those are first. multiply and divide, and the modulus, those are next on the hierarchy. Adding and subtracting, then shifting. Shifting, if you remember back when we talked about binary or with variables, shifting is when you actually look at the byte values, like the binary inside of a number, and you shift the bits left and right, right? This is, I'm forgetting off the top of my head, but these are like shift left and then whatever you pad or you replace, in other words, the bits on the ends with zeros. And then you just shift everything else to like the left or the right. And then I think this one is you shift but pad with ones. I might have that backwards. You can Google this though if you want to double check my work or what I'm saying here. Which ones pad with zeros and which ones pad with ones. And then relations, which is what we're talking about right now. Less than, greater than, less than or equal to, greater than or equal to. Don't worry about instance of. Equality. Are two things equal or not equal? So these should actually have the same precedence, but let's see, bitwise and. Then we have these are binary operators, the bitwise and the bitwise and bitwise. That's why they're called bitwise, is because what and does is it does an and comparator, but it goes bit by bit to determine what it is. So if I had, where's some space I got here? Okay. So if I had the number 0110 in binary, and then I had another number and I said 0101. So what is that? 0, 1, 2, 3, 4, 5, 6. So this is actually 6 in decimal, and this should be 5 in decimal. If I say like C is equal to 6 single ampersand 5, this is actually doing a comparison bit by bit. So this will actually become a 0 because this is only true if both are 1. Only true if both are 1, so it becomes a 0. Only true if both are 1. And then only true if both are 1, so it's a 0. What is that in binary? So that's 0, 1, 2, 3, 4. C will equal 4. Not true or false, because we only generate true or false, in other words, zeros or ones, in this case, zeros or ones, based on the comparison of bit by bit to generate a new number. That's what bitwise and bitwise exclusive OR and a bitwise OR are. It's the same thing as what they are for the whole numbers, except it goes bit by bit instead of comparing the whole number all at once. And then we have our logical AND and OR, which is what we just talked about. Compares to full numbers, right, as just values, not just binary, just as values. We're going to skip ternary and assignment. Never used either of them. Don't care. Actually, I will talk about a couple of these assignments, plus equals and minus equals, for just a second here. Why is this unexpected type require variable found value? Okay. Oh, because you can't do plus 6 on this. You have to do plus d. Don't worry about that though. Okay, so actually, this is a good time to talk about that. So in here, I have int d. There are two ways I can increment d by 1. I'm going to do this at the very end. I'm going to take d and bring it all the way back down to here. I can say that hi, int I, equals d plus plus, right? And at the end of this line, it'll be 7. So I will actually be 6 because it doesn't increment till the end of the line. So if I print this, it'll be 6. But there's another way that we can increment something. You could also do plus equals I plus equals d. However, this is different because this is the same as saying I is equal to I plus d. That is the same thing here. So just like how plus plus and minus minus are shortcuts, plus equals is a shortcut for saying I'm going to take myself, I'm going to set the value I want for I is going to be whatever it is now plus the value of something else, in this case d. So you can also do this with minus equals, times equals, divide equals, and equals, mod equals, or equals, anything. These are shortcuts. So plus equals D. And this is a really good way of doing counters, right? So we're going to see we're going to do plus equals like 2 or 1, right? If I want to count up by 1 after so many times or every so often, I can just do plus equals 1. All right, I promise this is all going to come together in just a moment. And let's see, we make one statement where they assign a Boolean value from the usage of Boolean operators and comparators. We already did that. All right, here's where things start to get a little bit more interesting. If statements. We can use the result of a Boolean equation to determine whether or not we should use something in the form of if A or B, or if a condition, then do B, otherwise do C. So this is a way to get a computer to kind of branch itself, because as of right now, our programs just go one line at a time until it hits the last curly bracket, or the last curly bracket, the closing curly bracket of the main method. We keep going line by line and that's it. It's a very linear, boring ass program. But here, what we're saying is now we can add some variety to our programs. We can say if this condition, then do this, otherwise do this. So we're going to do this one piece at a time. We're just going to look at the if statement. Then we're going to look at else if and then else. I'm running out of kind of ideas here. I plus equals 1. Is it because I didn't initialize I? I equals 0. Let's just call it that. And then I plus equals 1. Stop complaining. Good. Okay. It's probably because we didn't initialize I, so it didn't have a value. So it didn't know where to start. It's telling it to increment by 1, but I forgot to actually assign it a value to start with. All right, sweet. What were we doing? If statements. Okay. Let's do this. Let's uncomment these values. And we're going to recycle them right now. I still want to comment that out. I want to comment this one out too, so we're not constantly printing out statements. Cool. So we have some Boolean values. Let's use them for a second. Let's just create a simple if statement. First, I'm just going to type if, and then I'm going to close the parenthesis. Now I get to do a comparison. The comparison must yield a Boolean value, right? So if I say if A and B, so for a moment here, just so this can actually execute, we'll set this to true. If A and B, we need to do a curly bracket and the curly bracket. So now what's saying is we're going to compare A and B. If this yields a true, and that's kind of the key thing, the final value of what's between these parentheses has to be true. So if A and B equals true, or yields true, then I want you to do something. What we'll do is we'll do system.out.print line D plus E. Okay, so this should yield 6 plus 8, which is 14. Right, so let's compile and run just to make sure. All right, 14, perfect. That means, that we created a true statement and then we entered it. If I said that one of these was false, and as we just discussed, since they're not the same and this is an and comparison, this will yield a false. Right now, what it'll do is it'll just skip everything until the second curly bracket and then just move on. So this time, we shouldn't print anything. In fact, I will force it to print something. System.out.print line something. I don't know. Right? Because it's not going to print the 14. You're going to have a C14 on there, but that's from the last execution of it. Okay, something, right? This 14 came from the last execution of the program, so we'll clear it out just so we're not getting confused again. Okay, so that's good. we can tell it, now we can at least tell it, okay, if something, then do something else. We can make this much more complicated too, by the way. We can say if those two are true, or if E is greater than D, then true. So this is something we haven't seen yet. So let's kind of analyze this and break it down piece by piece. We need to kind of do this OR comparator, but remember that this only compares Boolean values, and the and the greater than or equal to, these are actually of a higher hierarchy. So this is a Boolean comparator, Boolean values must be on both sides, and this is a integer comparator. So if you look at this, that means that these two have to be done first, right? So we have E greater than D, which in this case, E is greater than D, so this will be true. And A and B, which is false, is going to be false. So now, let's see if I can, yeah, there we go. I got some space up here, yes. Let's start from left to right and do this in order, since these, if we look back at the hierarchy, right, which one comes first? So the relational goes first, right? So in this case, E is greater than D, which is true. So we start with A and, oops, B, or E and D. Okay, so I said the relational values have to go first. So we're going to end up with A and B. I'm just bringing it down to make it to the next line. And E is greater than D is going to be true. So I'm just going to put a T for true. Next on that list of hierarchy, we know that the double and, the logical and, is next. Well, logical and or. So which one goes first, since they're both of the same hierarchy technically? I could switch this, but it'll still do what I'm about to do. It's going to go left to right. So in this case, it's going to go A, which is, I believe, true, and B, which is false. So this comparison will yield a false. So now we're left with a false or a true. This, since it's an OR logic, will yield a true. And put that there. Okay. So what this will say is if the two Boolean values are the same, or if E is greater than D, then do this line of code. And as we just showed, we know that this will yield a true based on these current values up here, right? Is E greater than D? Yes. Or is the other one true? It actually doesn't matter. We already know that it's true. This will actually omit this because the OR is called shorted out. When you do an OR comparison, this really isn't that valuable to know, but if you do an OR comparison and the first and the hierarchy comparison is true, the first comparison you do is true, it will actually skip even checking the second comparison. Now this is unusual because usually we go from left to right, but in this case we actually had to do this one first. So this is true, it won't even actually check this, but in our case we did it by hand anyways over here. So we're going to do it, we're going to say that it executes. But anyways, we do know that this will be true, so therefore we know that it'll print D plus E. So now, if I compile and run this, something and 14. And that 14 is not from the previous execution. Otherwise you would have seen something at the end, but we didn't. Okay, so that's how you make one comparison. However, this is not necessarily that useful by itself. What if I want to do something where it's like, you know what? I want to create 3 conditions or multiple conditions. I say, let's make this simple just to kind of look at this. If A and B are the same, if A and B are equal, I want you to do the first one and then skip all other kind of options. If the first check, we'll call these checks, if the first check is false, I want you to try this secondary check. If that fails, I want you to try this tertiary check, right? And then this fourth check and fifth check, etc. What I can do is I can type in else. Let's do it on the next line. Else if I want you to check if D is equal to E. I want you to check if D is equal to E. If it is, then we want you to do system.out.println, and we'll actually do, second check. And let's actually change this to be first check. Okay. And then I can add another one. Else if, let's see, G equals H. System.out.println third check. Right? This is saying like if the first check here, if the second check here, or this third check, second check or third check, print out the one that's underneath it. So here's how this works. It's going to go in order. Right? It's going to check the first one. If it's true, it's going to execute this line of code, then skip all the other associated else ifs. So you have to have an else if after an if, and right now it would be tied to it. If I put another if statement underneath here, it would not have anything to do with this first one because we've cut it off. We've stopped it and we've started a whole new if group of checks. So in this case, it's saying if A and B, if this is true, then do this one line of code and skip every else if in the group and then just go to the bottom. So I'm going to actually delete this. I'm just going to comment it out actually. Right? But if the first one is false, then do the second check. If this is true, then print this. If this is false, go to the next check. If this is true, print this. Right? What if all of your checks fail, but you still have something in mind that you want your computer to do? You can do what's called an else statement. So else will look like this. It'll just be else. There's absolutely no comparisons inside of it. Right? It's just else right by itself because there is nothing to check. It's basically saying if all else fails, do this one thing. All checks failed. Right? I don't even remember what our values were, but let's go ahead and see what happens. And see if we can kind of work backwards actually to determine its value. Third check. Okay, let's see what happened. So we know that it's the third check. So let's work backwards or kind of go forward, I guess. Let's start at the top. Is A equal to B, or are A and B the same? No, because we know that one is true, one is false. So let's skip that. Go to the next else if statement. Is D equal to E? Well, these are integer values. Remember, that's why we're doing equals equals and not and. So does D equal to E? No, 6 and 8 are not equal to each other. System.out.println, we're going to skip this line. What about G equal to H? Well, yes, they are the same, but what happens if I do that? Hello and hell. Now they're not the same. Actually, let me clear this out real quick. And we already compiled because we don't see the lines. All checks failed. So it doesn't mean, well, actually, because we have an else here, if everything else fails, print all checks failed. That's why we got this value to print out. Right? So now what you can do is you can create some sort of logic tree that says if condition A, if condition B, and so on, then do these things, right? And we saw a more complex kind of thing of this. So let's do an else if statement. And what I'm going to do here, what we're doing here is we're going to make a complicated one where it kind of includes all three of these, just so we have an example of how to make more complicated comparisons and not just single, this is one comparison, this is one comparison. Let's kind of stack a couple on here just for the sake of having examples. It's a legal start because I have no values in there. If A and B or D not equals E and G not equals G equals H. System.out.println fourth check. Okay. So now that you have this, feel free to kind of go back through your variables and start changing the values to see how it will go from one to the other, to the other, to the other, to the other. Okay. If you want to kind of input the values yourself, then you can create a scanner object. Take a look at the last video on how we got input from the user. You can do a little Googling to see if it's different for Boolean values or string values even. It shouldn't be, but not for string values. You just do, remember, you just do in.next. If you want integer, you do in.nextInt. You can do in.nextBool, I believe. You can Google it, in.nextBool, and then you have to type true or false just like this in order for it to kind of work. It'll know how to parse the string. Parsing means convert the string from a textual true, because when you enter it in as a string in the terminal, technically it comes into the computer like this, right, where it's green because it's a string. It'll read it and it says if the first character is a T, the second character is an R, the third character is a U, the fourth character is an E, then convert it to a Boolean and set Boolean value to true. It does that a lot in the background. Don't worry, we'll kind of go over that at another time. But feel free to start manually messing with this so we can compare or do selection manually. Or if you really want to take it to the next level, get input from a user and see if you can kind of manipulate the outcome from that. Okay. Nesting. Ooh, I almost forgot about this one. The term nesting means to put something inside of something else. So to nest something, I can nest if statements, right? So I can say if A and B, and then inside if A, let's say if this is true, I can actually put an if statement inside of here and say if D equals, if D not equals E. This is starting to get really kind of weird, but the key here is that it has to pass this comparison first. Then inside of it, we'll do a secondary comparison. Yes, this is the same thing. In this case, this would be the same thing as if A and B and D not equal E. In this case, it would be the same thing. However, what if I wanted to print this out first and then do this check? If I were to do this, if I were to do and D not equals E up here, this would actually, if it fails, if this turns out to be false because I'm doing two comparisons, comparing the two comparisons, it would skip this. But what I'm saying is I want you to first check A and B. If it's true, print first check, then do another check. And then, we can do like system.out.println nested check. Nested check 2. Okay. You can nest ifs, and then we can obviously do else if. We can expand this to be else ifs and else's, just like we did over here. I'm just trying to keep this as simple as possible while including every example I can think of. You can nest an if statement, meaning that you can put separate if statements inside of another if statement. Okay. We will actually do this a lot when looping. So loops we'll cover on the next lesson, but we're going to actually nest loops a lot. But comparisons are actually very useful to nest as well. Okay, let's make the following program. If you want seafood, eat at Chicago's, because I'm from Chicago. So let's eat at Chicago's. Then, if you want seafood and you have $50, order the lobster. Otherwise, order the shrimp. If you don't want seafood, eat at Weber Grill. If you have at least $50, order this. Okay, so on. So let's create a new project. Let's compile just to save it. Control save. And let's create a new project. What was this? Lesson 3. Lesson 3 try. Okay, we're going to create a new class. And that class is going to be called dinner selector. This is Boolean practice. Let's close that. And let's bring the instructions up on the right. Okay, cool, perfect. Get rid of this. All right, remember, got to start somewhere. Public static void main string args. Okay, so let's create a variable. So Boolean is wants seafood. And for now, let's just set it to true. We'll change that in a second. Boolean, no, let's create an integer. Int money equals 45 bucks. Otherwise, order the chicken tenders kids meal. And let's make a string. Do I want to say restaurant? Yeah. And we'll set it to just an empty string for now. Okay. Now, this says, if you want seafood, if wants seafood equals true, because you can compare it directly to something. If want seafood equals true, then check to see if you have $50 or more. If you have $50 or more, order the lobster, otherwise order the shrimp. Now, why am I not doing this? If true and money greater than 50. The reason I'm not doing this is because if you look carefully, it says otherwise order the shrimp. I can't. Whoa. Okay. If I have $45, this will just skip. But remember that I do, if I want to eat seafood, then I'm going to order at Chicago's. But this is going to say if I have less than $50, don't eat at Chicago's. It's going to go eat at Weber Grill, but that's not what I said. I said if you want to eat at seafood, then go to eat at Chicago's. If you have less than $50, then order the shrimp. So that means that I can't put these together. In fact, what I have to do is nest the if statement. If money greater than or equal to 50, oh, I forgot. String, oh, sorry, restaurant. God damn, I can't type. I can't even spell anyways. Eating at Chicago's. If money, let's actually create one more string here. Sorry, string dish equals blank for now, and we'll populate it in a second. If money is greater than or equal to $50, dish equals shrimp. Oh, I'm sorry, lobster. Oops. Else dish equals shrimp. Don't forget your semicolons, by the way, guys. Conditionals end with curly brackets, right? But statements, individual lines, the statements, they have to end in semicolons. Okay, so let's kind of walk through this right now. If you want seafood, then eat at Chicago's. If you have if you have $50 or more, get the lobster. Otherwise, get the shrimp. See, there's two reasons why I didn't put this comparison up here. One is because I know that just from that one condition alone, if you want seafood, you're gonna go to eat at Chicago's. I'm saying that it's going to happen. If you bring in any other logic, then you're actually kind of modifying this statement and not taking this as a separate condition. So if I have more than $50, then eat the lobster, otherwise get the shrimp. That's it. That is the only thing I need to kind of compare for that. The next thing to say is if you want seafood, if you don't want seafood, so the only other option is I could do else if wants seafood equals false, but I don't need to because the only opposite to this is false, so I can just do else. If you have at least $50, if money is greater than or equal to $50, oops, oh no. Dish. Oh, first of all, I always forget this. At Weber Grill. Not sponsored by Weber Grill at all. Dish equals porterhouse. Oops, I forgot quotes. Porterhouse. Now I need an else if condition. If else if is greater than 30. Now, some of you may think that you should do if money is greater than 30 and money is less than 50, but you don't technically have to do that because if it's greater than or equal to 50, it's going to skip this comparison anyways because this will be true. And then remember, if one of these conditions is true, it will skip all the subsequent checks. So all the else if statements that follow it will get skipped. So this would be, you can do this, there's nothing wrong with this, it would just be overly redundant. So if money is greater than 30, so I can just leave it at that. Dish equals filet, double quote, not single quote, filet mignon. Else if money is greater than 20, dish equals burger. Damn it. Otherwise, in other words, just a plain old else, dish equals chicken tendies. All right. So this is the end of that else statement. And at the like system, at the very end, I just want to print the everything together. System dot out dot print line. I always like doing the line the most. Let's say restaurant plus. I think I forgot a space. You know what? This makes it a little bit easier. I'm gonna put a space in front of everything over here. Otherwise, I'm gonna have to put the space down there. And that might just get a little annoying. So restaurant plus dish. That's it. Let's see what we get. Was there anything else? Restaurant plus dish. No. Compile. And so if I want seafood, which is true, and I have $45, I'm going to order the shrimp. Let's make sure that that happens. Eating at Chicago's shrimp. Restaurant plus, let's modify this to make it a little bit more normal to read. Eating at Chicago's and getting the, I don't need the space anymore. Okay. And getting the lobster, shrimp, porterhouse, filet mignon, burger, chicken tendies. Let's make sure we get down to the chicken tendies. Let's say that we have to have less than $20. So let's say we have exactly $19, and I don't want seafood. Right? Keep going away. Eating at Weber Grill and getting the chicken tendies. There you go. Get your tendies, boys. Okay, sweet, perfect, excellent. There's another type of conditional selection. There's another type of selection called switch statements. These are a bit different and have kind of like two uses. The most common use for this is when you have usually a numerical value, but you have a lot of different statements. Can you imagine if I had 50 different outcomes based on my money? If I wanted, like, do you want to eat at a seafood? Do you want seafood or not? But then, have options for 10, $100, $90, $80, $70, 60, 50, 40, 30, 10. It would take forever and just be a pain in the ass to kind of reprogram that to make it work right. Or not to work right, I'm sorry. It would be a pain in the ass to kind of sit here and make if this, else if that, else if this, else if that, else if this, else. So what we're going to do is, instead of making a ton of else if statements and needing a lot of very simple checks, we can use a switch statement. For example, if we have an integer, call it sum, and that equals 1, right? Something. You can take a switch statement using the variable sum, and then where the case is where it equals 1. This is not just case 1, like, oh, this is the first condition. No, it's saying that if sum equals 1, in the case where sum is 1, do something. If sum is 2, do something else, and then break. Default is kind of like saying else if. Oh, it's not else if, just else. Do nothing, break. By the way, these are called functions. I really wish I didn't put that in here, but we'll show something in a minute. This statement is fine, but let's see what happens for sum equals 1 since there is a missing break. Okay, let's replicate this and look at how this works and then modify it to kind of work a little bit better. Int sum equals 1. Switch sum do I need, oh, really? Curly brackets? That's new. Oh, that's what it was. Oh, crap. I didn't mean to actually put that there. Okay. Sorry, made a mistake here. It's not curly brackets, I forgot the colon. That's what you do. My mistake. Sum that case 1. I'm sorry we're printing a lot, guys. Value is 1. I don't know, I'm out of ideas here. Case 2. Value is 2. Break default unknown. I don't know, something else, something else. Come on. Break? Why did I put a break there? Oh, you know what? The mistake I made? Okay, here it is. I'm gonna have to kind of edit this a little bit. Let's put that there, and this curly bracket will close it. So we've got to put this over to the side. Put that there, and let's shift this over also. There you go, perfect. That's what I want. Okay. So now you'll notice that the errors are gone, and I was gonna show you something before. Actually, I am gonna explain it. I was gonna not explain it, but I'm gonna explain it. This is actually a very bad way of doing switch statements, so we're gonna fix this in just a moment. But let's step through this and understand what happens. So we start with our integer called sum. And right now it has a value 1. You can grab a value from wherever you want. The switch statement's first going to take sum, which is going to be 1. It's going to go case by case and check case this, case that, and then it's going to, if it ever is true, it's going to shift to the right side of the colon and then execute that line of code. For this case, we're just printing out this string. The thing is, in this case, it's going to go to case 1. It's going to execute system.out.println, but as soon as we switch from the left side to the right side, we're just going to keep going down the printing code until we hit a break. Once we hit the break, then we kind of jump to the end of the curly brackets. So if I were to run this right now, it would print value is 1, value is 2. Value is 1, and the next line value is 2. And then it would break, which would skip the default and go to the end, right? But I don't want that. What I want is for it to break after whatever it is that it's the value of. So if I actually leave that there, compile this, value is 1, value is 2. I don't want that though. I want it to be, why am I at the top? Break, there. I want it to stop executing the right-hand side and then just jump to the end. Compile, run, damn it. There you go. Value is 1. And no, it's not printing value is 2. Okay, clear this. Control K next time. And let's say that the value is 3. Obviously, this is a... Why did that move? Why is that moving? It will fail, but there's the default. This is just like the else statement. Default value is something else. I already compiled. Not again. And the string here. Value is something else. Not too bad. So this is obviously very simple. It's only 2 case statements, but you can have hundreds. You can actually have as many as you want, as long as they're the values. Now, if I did string, if I switch this to string, and I said, let's say, string, I don't know, day, right? And I said I could have this be Monday. Oh, sorry, not day. What am I talking about? Day. Not just Monday. Right? Print, I guess Monday. Oh, this is different because this is a lowercase. And then I have to switch this to day. Okay, let's see what this yields. This should be, it should print, you know what, I'm just gonna actually leave this alone, values 2, since it's not gonna be that anyways. Compiled, run, go back, Monday, ta-da! So the point of me doing this is to show you that this doesn't have to be a number. It's not like first case, second case. It's just case, it's comparing this value to this value. That's all that's doing. That's kind of what I'm trying to show you here, and which is why I switched it to strings. So we already make a switch statement, and it looks like I'm at the end of my PowerPoint here. Okay, we covered a lot. This should help you guys add a little bit of variety to your programs. A little bit, not a lot. You know, we're still starting off. I think the next one, I have to check with my schedule, but I think the next one is looping. So we're going to be using selection in order to repeat a process over and over and over again, which is actually going to be very helpful for us in the near future. Actually, forever. Loops are extremely important. So stick around. We're not at a point where I feel like we're really going to be comfortable with the way that we program yet, but we are getting very close. So hang in there. I know this is not the best or most interesting programming ever, but we're almost at a point where we can at least start to make some genuinely interesting programs. So I'll see you in the next lesson. Last minute edit here. I forgot to actually mention something. If your if statement is a single line, you can actually make it you don't actually need to use curly brackets, and your your program will still compile. If you add a second line, say dish equals I don't care, it doesn't matter. Now Java is going to complain because you got too many lines, it doesn't know where to stop. Java needs those curly brackets unless you have only one line. In other languages like Python, you don't need curly brackets, you just have to use tabs. But since Java ignores white space, you have to have the curly brackets, but you're given one line of kind of leeway here to do this. Okay, just wanted to mention that. Sorry about the switch statement thing earlier. Don't really use switch statements too often, but we got to the correct switch statement by the end of the lesson. So thanks, and again, see you guys in the next lesson.